So let's jot down some thoughts, some things that we want to make sure that we remember about this chapter. I know for my z-score, one of the things that I always write down is z is equal to x minus mu minus the mean divided by sigma, divided by the standard deviation. That is exactly what it says right here in words, but remembering it in symbols is going to be more useful as you're going through and solving problems. Interpreting our z-scores, a z-score of whatever your z-score happens to be, is that many standard deviations above or below, above if it's positive, below if it's negative, the mean. The percentile is the percent of scores below a specific value. This is at or below the value. Yes. Correct. We never say in, we say at. At a percentile, never in the percentile, yes. And that is how I would interpret it. I would say, a score of this, say Utah has this many or more schools than blank percent. And yes, we are always at a certain percentile, never in the percentile. All right. 68% of the data is within 1 standard deviation of the mean, 95% is within 2 standard deviations, and 99.7% is within 3 standard deviations. What is this called? Yep, you can call it the 68, 95, 99.7 rule. You can also call it the empirical rule. Those two phrases get used interchangeably for this rule. You can refer to it by number or by name. That is both considered to be correct. This is always for a normal curve. A standard normal curve has a mean of 0, and then there's a typo in your packet. That is not the right symbol for standard deviation. That should be a sigma. This is your standard deviation. And this is used with z-scores. So if they give you a z-score, they are giving you a normalized value, a standardized value. Normal CDF to find the area under the curve. And we use inverse norm if given the area. Write a conclusion in context for word problems. So if they give you a word problem, you should answer back with a sentence. A lot of times your sentence is just going to be parroting back their question stem with your answer filled in. But you want to answer back in sentence form. All right. And then we have some examples of interpretations. Percentile, the percentile of our context are less than or equal to the value. So 75% of high school student SAT scores are less than or equal to 1200. Interpreting a z-score, the specific value with context is z-score standard deviations above or below the mean. So a quiz score of 71, that's my specific value with context, a quiz score of 71, is 1.43 standard deviations below the mean. So that would mean it has a z-score of negative 1.43. Anytime we are below the mean, the z-score is actually a negative. Describing a distribution, this is just rehashing SOCs here. Shape, outliers, center, and spread. We practiced that in chapter 1, so I'm not going to go over that again. Yes, sir. Yep. Angle STR, this angle right here, is 126 degrees. If we know that that's 126 degrees, I want you to find angle RTP, this angle right here. A couple other things that I would make sure to get written down here on this page. Let's go ahead and draw our standard normal curve. Right down the center is where we put the mean. We have some value on the x-axis here. I'm going to call that actually a capital A, some value A. And then we have it shaded. You need the capital N with the mean and the standard deviation labeled. My inequality notation would be the probability that the number on the x-axis, P of x, is greater than A since I shaded to the right. That would be normal CDF. I'm running out of room to write this. There, I'll put it down here, I guess. And then I would have my lower bound, which in my picture is where A is. Then we would need our upper boundary, something really big, labeled as the upper boundary. Then the mean and the standard deviation. And that will give us our percent or our proportion. This is what you do when you need to find a percent, a probability, or a proportion. You are finding the area. You are finding the area that has been shaded. When you have the percent, that's when you do inverse norm. And you put the area in first, then you put the mean and the standard deviation and the tail direction. And this gives a value. Thank you, Derek. All right, two more things that I want to get jotted down on this page that I think are important. To transform data. We do A times the mean plus B to transform our mean. And we do A times the standard deviation to transform our standard deviation. There's no pluses or minuses when we transform our standard deviation. For a uniform distribution, the uniform distribution would be something like this. It would be the rectangle. The area is equal to 1. So if we go over to 6 on the x-axis, then it would go up to 1/6 on the y-axis. Because 1/6 times 6 equals 1, and that's the area. So however wide the rectangle is on a uniform distribution, the height will be 1 over that number, so that you have a total area of 1. All right. Did anybody have anything else that they wanted to add on to this? These are all things that I feel are really important about Chapter 2 that we're going to need to remember all the way from now until May. We will have the chance to practice with all of these things again. It's not like once we go to Chapter 3, we just forget Chapter 2 stuff. We will come back and circle back on these ideas several more times. For the remainder of your time in class today, I want you to do some multiple choice practice. Also, if you did not pick up a copy of the paper test review, you want to make sure to grab a copy of that before you leave the room. That's in the tray over here. You'll want to work on that over the weekend. Your test is on Wednesday. For the remainder of the class time today, I want you guys to do some multiple choice practice. You have 2 choices for your multiple choice practice. Guys, multiple choice practice. There's a multiple choice practice in Canvas that is auto-graded, so it will give you immediate feedback on whether you got the questions right or wrong. You have to use your Pike student account to log in to do this. It's a Google form, so you have to be logged in your Pike student account. The other option is I have 18 multiple choice questions spread around these 3 walls of the room. You are welcome to work on those. If you would like to save this one to work on later, you may work on the ones around the room as well. They are not the same questions, so you can get additional practice that way. But I would like for you guys to work on multiple choice for the rest of the time here today, and you absolutely are allowed to work together, whether you're doing the online multiple choice practice or the around the room multiple choice practice.
You speak Spanish?